I'm excited to tell you about Mars today because as it now shines once again like a shiny new penny in the sky, it gets me to thinking about why humans are so fascinated by the red planet. This planet is really captivating. In fact, it is so captivating that we have literally thrown billions of dollars worth of metal at the planet just to go and study it. But before that, we built entire observatories to look at this planet. And before that, we used our eyes. And it's always been something that has fascinated humans. But what you might not know about Mars is that it is at least partially responsible for ripping the Earth out of the center of our universe. I'm going to tell a little bit about that story as we go on, as well as a history of the observations that humans have made about Mars over the years. So as you probably know, Mars is visible right now. It's low in the east, just after sunset. So this view is from Toronto at about 7:30 at night, and it was generated by the Stellarium software, which I imagine many of you have seen or used yourself. There are no particularly bright stars nearby. This program shows a few in the sky, but from the city, you won't see very many. If you know your sky, you'll know that Mars is actually within a constellation called Pisces the Fishes, which if you have a good imagination, looks something like this. You need a very good imagination. Mars is not the only planet that's visible in the night sky right now. In fact, there are two more. Towards the southwest, quite high in the sky, Jupiter is very bright, and Saturn is right next door. These two planets are in a constellation called Sagittarius the Archer. And you'll see Capricornus off to the left, near Saturn and Jupiter. So Pisces the Fishes, Capricornus, Sagittarius, all very familiar names, I hope, to most of you. These are constellations of the zodiac. Those are a set of 12 star groups that lie along the path that the planets travel in the sky. The planets do not deviate from the zodiac. They're always found in there. And that traveling that they do is just a reflection of the fact that the planets are orbiting the sun. But back in ancient times, that traveling actually gave the planets their name. The name planet comes from the Greek planetes. Planetes asteres meant wandering star. And the ancient peoples of the world knew about 5 wandering stars. There was Mercury, the winged messenger, Venus, the goddess of love, Jupiter, the king of the gods, and Saturn, the god of time. These at least were the names that the Greco-Romans gave to the planets, which were adopted by most European countries and cultures. So Mars, though, was the god of war for pretty obvious reasons. It looks red in the sky, but there's another thing about Mars that makes it warlike. Not only does it remind us of the fires of battle, it also is kind of fickle and unpredictable. In fact, it's the movements of Mars that likely helped it rip Earth out of the center of the universe. So I want to tell that story. So Earth at one time was considered to be the middle of everything. So you probably know people who still think they're at the center of the universe, but it was actually a fairly natural thing for people to think that Earth was in the middle of everything, and all of the planets, the moon, and the sun all went around us. Nowadays, of course, Earth is the third rock from the sun in this very inaccurate model of the solar system. And as I've said a couple of times, Mars was one of the reasons why it got moved out there, because Mars moves in a weird way. It's really noticeable to people. And that weird motion could not be explained by the way people used to think of the universe. So this photograph on the left, which was taken in 2018, is kind of like a time lapse of Mars when it was at opposition, which, as you likely know, is when Mars is brightest in the sky. That's when Mars sits directly opposite the sun, which is why we see it in the east right now as the sun is going down in the west. And the photos show Mars not only getting sort of dimmer on the side of the image, and as it gets towards the center, it brightens up, but it also makes this weird loop, and that's called a retrograde loop. The nice little animation on the other side, which I got from Wikipedia, shows why this happens, where you have the sun in the middle of the diagram, you've got Earth orbiting around the sun, and as Earth and Mars get to be in the position where they would be during opposition, Earth overtakes Mars, and from our perspective, Mars moves backwards and makes a little loop in the sky called a retrograde loop. So that's pretty easy to understand. It's not very easy to understand if you have the Earth at the center of the universe, which is how things were. That's what people thought. This is how they thought it worked. So Earth was in the middle, and everything went around us. And not only that, everything went around us in circles. Everything had to move in circles. So how do you get Mars to do a loop-de-loop in the sky if everything is moving around us? It's pretty hard to do. But fortunately, people back in those 2,000 years ago had very active imaginations and were good mathematicians. And they came up with an idea where you could have the planet moving on a little orbit called an epicycle. And the epicycle then moved on an orbit, which is marked in the light blue here, going around a point in the middle, and Earth is on one side of that point, and this other fictitious thing called an equant is on the other side. So you've got the planet moving on an epicycle, you've got the light blue path that the epicycle orbits on, which is actually called a deferent, by the way, and a fictitious point called an equant. And if you put all of that together, you can make Mars make a loop. Now, Mars wasn't the only planet to do this, so to actually get the universe to behave as you wished, you had to have every planet doing this. And here's a lovely animation that I found on YouTube of the weird way that they thought the solar system would work way back a couple thousand years ago. Actually, this model persisted for quite a long time until eventually these four guys and a few other people came along and said it's way too complicated to make our universe like that. So we're going to revolutionize it. Now, they didn't know it at the time. In fact, person in color on the left is a guy named Nicholas Copernicus, who mathematically figured out that you could actually make the solar system much simpler if you just stuck the sun at the center of it. Next to him is Tycho Brahe, who made observations specifically of the planet Mars, which were then used by Johannes Kepler next to him, who mathematically looked at all of these observations and figured out the mathematics around putting the sun at the center of the solar system, or the universe as they knew it. And then finally, Galileo Galilei, who invented the telescope. Sort of, he kind of popularized the telescope, turned it on the night sky in 1610, and actually found observational evidence to support all of the ideas that the other people had. I want to go specifically into Tycho's observations of Mars, because he was actually operating before Galileo turned his telescope on the night sky. So he didn't have a telescope to use. He just used very accurate observations. And you can see in this image, there's sort of a graduated circle that he could use to help make measurements. And he did this in an observatory in Denmark, a little island. He had the whole island to his observatories. He did that for 20 years and painstakingly made these observations and wrote them down and then gave them to Kepler, kind of begrudgingly. That's a whole other story. And Kepler then used all of these observations to create his mathematical concept of how the solar system might work. So it was really these Mars observations that put the final nail in the coffin of the old Earth-centered universe. Interestingly enough, Galileo himself didn't say a whole lot about Mars. And I say that because Galileo, apart from Copernicus, is probably the most famous person involved in the Copernican revolution to move the Earth out of the center of the universe. But the reason why Galileo didn't say much about Mars is likely because it doesn't look like much through a telescope. So I've got a little simulated gray circle here, which is kind of showing what Mars would look like through a Galileo-style telescope or a small telescope, just a little red dot, very few features. On the left, I found this on the internet, somebody who had a Galileo replica telescope and they turned it on Mars and did this lovely drawing, very featureless. And then I happened to notice after that the drawing was made on April 1st, so I don't know how realistic that really is. Anyway, the observing technology when we first started having telescopes was pretty basic. This is one of Galileo's telescopes from the museum in Florence, and it is about the same observing power as half a pair of opera glasses that we might have now, and the optics wouldn't be nearly as good. Things did get better though, and by the sort of mid to late 1600s, there were massive telescopes, this one built by Christian Huygens, who used it, and others that he built to make more accurate and detailed observations of the planets. Huygens actually discovered the rings of Saturn with a telescope like this. And on the one side, you can see a drawing that Huygens made of the planet Mars with these sort of dark patches on it. So first hints that there were actually details on the surface that you could see. Another quite famous astronomer a few years later, William Herschel, working in England, actually looked at Mars and noted that there was a slight lightening to one side. So it got a little bit brighter. But he didn't think much of that because he was more interested in comets, so he basically ignored it. But what he probably discovered was the Martian ice cap. It has two, one in the north, one in the south. As things got a little bit better and astronomers got better telescopes, better technology, a little bit settled down, and started to look at Mars systematically, you began to see drawings like this where you see more details on the surface. And this actually reminds me of the first time I really noticed details on the surface of Mars, which was observing with my friends in the RASC down at Humber Bay Park during one of the oppositions of Mars in the 1990s. We had a very stable night one night, and looking through the telescope, I could see the polar caps, and I could see this dark patch in the middle of Mars that I now know is Syrtis Major. And it was pretty incredible to get that kind of detail. But you still couldn't see a lot. And through these telescopes, it was pretty easy to fool yourself into seeing things that maybe weren't there. Let me just back up a bit. The most famous map of Mars was made by Giovanni Schiaparelli, who actually sat at his telescope with a little eyepiece with crosshairs in it and slowly and methodically observed the planet and noted down the details that he saw and created incredible maps like this. Schiaparelli also introduced sort of standard nomenclature for things on Mars, and these are very evocative of Earth features. So you have the mare, the seas, just like on the moon. And you also have lakes and swamps, and there were very interesting features there, bays, lovely names actually. But he and another Italian observer, Father Secchi, who was known for discovering a whole bunch of interesting things as well, were looking at these maps, and Secchi said, you know, it's almost like there's canali connecting things on Mars. Canali is an Italian word that translates to channel, but it was mistranslated by many to be canals, which has a much more kind of built connotation to it than a channel does. So that became the next big thing in Mars observations. Were there canals on the planet? And if so, who built them? Schiaparelli and Secchi really bought into this idea and eventually created maps with all these canals named after famous rivers on Earth, like the Ganges and the Euphrates and the Indus. But not everybody was convinced. Otto von Struve sums up the general opinion of the day, I think, when he said, I'm sorry to say that I have never been able to see the canals, but knowing Schiaparelli's excellence as an observer, I cannot doubt that they are there. And this comes up quite a lot. Those canals and the search for the intelligence, that built them took over the next almost century of Mars research. I'd like to show you one of the big advances in technology, big telescope on the top of a mountain outside of San Jose, California, the Lick Observatory and the Great Lick Refractor. I'm showing it partly because I love this place, but also because it nearly burned down this year during the California wildfires. Fortunately, it was spared this time. But there's a lot of history here, including observing Mars. And what you see is a drawing of Mars by the director of the observatory, James Keeler, who also thought that he could see canals. But he was puzzled because they didn't correspond to the ones on Schiaparelli's map, so not quite sure what they were. The Lick astronomers also announced that they could see projections beyond the dark edge of Mars, little kind of glowing things, and they figured that they were probably mountains on Mars, and after the sun set on that part of Mars, there was still a bit of sunlight glinting off the mountaintops. It's a familiar effect on Earth called alpenglow, and we've also seen it on the moon. But of course, in a wonderfully early bit of fake news, these became signal flashes from Martians trying to communicate with Earth. So this is when the press started to really take notice. Around the same time, a man named Percival Lowell, a very rich Boston man, became very interested in Mars as well, and he built an observatory in Flagstaff, Arizona. It's still there, the Lowell Observatory on Mars Hill. It's actually where the planet Pluto, or the former planet Pluto, was discovered. But before that, Lowell sat and made observations of Mars night after night after night and drew absolutely beautiful maps showing all of the canals that he thought were there. And he wrote a book called Mars as the Abode of Life, and it included beautiful descriptions like, far forest and still farther desert are transmuted by distance into mere washes of color, the one robin's egg blue, the other roseate ochre, and so bathed both in a flood of sunshine from out of a cloudless, burnished sky, that their tints rival those of a fire opal. Who could not be swayed by that? I mean, it's an incredible thing, and it inspired a lot of science fiction, and still does. Most famously, we have War of the Worlds, and we have Edgar Rice Burroughs and Princess of Mars. Mars was full of people at this point in our minds. But as photography became more possible and cheap, photographs of Mars didn't show these canals. This is a photograph from 1939, which remained for many, many years after the best photograph of Mars in existence. And though it is not terribly clear, you really don't see those straight lines that everybody had convinced themselves to see. And though this picture, as I said, was one of the most clear ones, and I would like to read to you a little excerpt from a brochure that used to be handed out at a planetarium. I worked at the Alexander F. Morrison Planetarium in San Francisco, and in 1954, they handed out this brochure to people about Mars that speculated about life on Mars. Still, not Martians walking around more, but vegetation. Because you see, Mars seemed to go through seasonal changes. And those seasonal changes, they thought, produced growing features that would sort of come and go on the surface. And the theory was that this was actually vegetation. A further argument in favor of the vegetation theory, says this handout, is offered in the very presence of the Maria, the seas. Only some form of hardy plant life, it is suggested, could give these areas their distinctive form. Without it, they would be overwhelmed by deserts, and the entire surface of Mars would be uniformly shaded. So that is 1954, still talking about plant life on Mars. And then the space age arrived. 1965, Mariner 4 flies by Mars, and this is what it sees. Not a particularly clear picture. Let's have another one. There we go. They were pretty disappointed to see that Mars was just a bunch of craters, much like the moon. Now, this was a fairly quick flyby. So later on, 1971, the Mariner 7 spacecraft became the first one to actually go in orbit around another planet. And it arrived at Mars just in time for a global dust storm, which obscured all views towards the surface. So it's kind of disappointing again, but after a few months when the dust cleared, they looked down and saw more craters. Again, not very exciting. But later on, things started to get more interesting, and features like this, a giant, apparently dried riverbed type feature, looked a lot like the Grand Canyon, was discovered. This was the Great Mariner Valley, named after Mariner 9. And it is one of the pieces of evidence that scientists now look to say that Mars almost definitely had a wet past. If it had a wet past, did it have life? Hard to know. Well, they're still working on it. I want to just say another thing about Mariner. As they were waiting for the dust to clear, one Mariner team member was a young Carl Sagan, and he began to speculate about the effects of a global dust storm. He actually came up with the theory of nuclear winter by looking at Mars like that, and that was one of the big factors that one could argue helped to stop the arms race, the nuclear arms race on Earth. After Mariner, a few years later, came the Viking Landers, Viking 1, Viking 2, that actually went down to the surface and stood on Mars for the first time. These pictures were incredible. Late 70s, early 80s, sent back. You felt like you're standing right there. The Viking spacecraft carried a remote laboratory so they could scoop up soil and actually test it to see if there were any biological processes going on. And guess what? They didn't find any. A few years later, in the mid-90s, this rock was found on Earth. It's a meteorite, but it tests like it is made of stuff that come from Mars. So they're pretty sure this rock actually comes from Mars. But inside it, as they were testing it, they discovered something pretty amazing, something that looked like a worm, but was much smaller than any sort of living thing on Earth. The speculation was it might be a bacterium, some kind of bacterium, really, really small on Mars. It really looks like a living thing. But most people now are not convinced. Although later Mars missions have found evidence again of the wet past and possible chemicals that might point to life having been on Mars in the past. Some people are still hopeful that they may find life there now, although I don't think very many people really believe in that. So the idea of life on Mars is still not put to bed. And why this is interesting is that as I started this little presentation, I said that Mars tore Earth out of the center of the universe and put it as a third rock from the sun, and then the sun just being one of a number of stars in our millions of stars in our galaxy, and our galaxy being one of millions in the universe. But also we said, well, that's okay because Earth is special. It has life. Well, now Mars is challenging that idea too, and recently Venus maybe. So life may be in lots of different places. So I think for me, the speculation about life on Mars is kind of interesting. It may just be wishful thinking, however. I mean, maybe we just really want to find life somewhere else, even if it's this guy worried about us blocking his view of Venus. But I think really that the thing that makes me very fascinated in Mars is how it allows us to look back at ourselves. When we look at Mars, we are looking at possibly our future and maybe our past as well. And this picture is perhaps one of my favorites ever taken. This is a view of the Earth taken from the surface of Mars. Can you imagine what those astronomers of the past would have thought of seeing something like this? It's incredible. Do you see any canals there? I don't know, maybe. Anyway, thank you for joining me on this journey through our history of observations of Mars. And I would like to wish you a very happy Mars opposition. Thank you.